All right, let's have a look at more calculations involving heat. Please remember that when you're doing calculations involving heat, if a system is losing energy, that energy must be gained by another system. Let's look at question 10. With all of these questions, please follow the steps above. Draw a diagram, write energy lost equals energy gained, and then substitute in where we are absorbing and where we are losing energy. In question 10, we're told that 200 grams of ice at 0 degrees are mixed with 500 grams of water at 80 degrees. Find the resulting temperature of the mixtures, assuming that no heat is lost to the surroundings. Okay, so first off, we're going to draw what we have. So we have ice at 0 degrees, and it's added to water, which is at 80 degrees. So what happens here? Well, our ice melts. So our ice must gain energy. To change state. And our water cools down. The final temperature of your ice water and your water will be the same. This is due to thermal equilibrium. Thermal equilibrium states that when two objects are touching, the amount of kinetic energy in both systems will be the same. All right, let's set up our equation. So the energy lost by one system will be equal to the energy gained by another. In this case, what is losing energy? Well, our hot water is losing energy by changing temperature. So our water is going to cool down. It's going to lose some of its kinetic energy. And what gains energy? So our ice gains energy to change state. So our ice will gain some energy to change state from ice to water. From here, we will have ice water at 0 degrees Celsius. And our ice water will then heat up. So our ice water changes temperature. From here, fill in our equations. Our energy lost by our water is lost by changing temperature. Therefore, our energy lost is equal to mc delta T of your water. The energy gained by the ice is the energy gained by the ice as it changes state, Lm, where L is our latent heat of fusion, as our ice is changing from a solid to our liquid. Once our ice changes state to water, it is at 0 degrees Celsius, so this ice water heats up. So it continues to take energy from that hot water until the hot water and the ice water meet and have a common temperature. So our ice water changes temperature. So our mass of our ice times the specific heat capacity of our water times the change in temperature of our ice water. Okay, now that we have our equations, we must fill in the values that we know. Starting on the left-hand side, m, our mass, is the mass of our water. We're told that the mass of our water is 500 grams. This must be converted into kilograms. Dividing it by 1,000 gives us 0.5. C, our specific heat capacity, is our specific heat capacity of water, 4180, times the change in temperature of the water. So our water is cooling down. That means it's going from 80 degrees to some final temperature. I do not know my final temperature yet. This is what I'm trying to find. So my change in temperature, delta T, is 80 minus my final temperature. Remember, when you're finding your change in temperature, it is always the smaller value from the larger value. Because I know my water is cooling down, it will be 80 degrees minus my final temperature, as my final temperature is less than my starting temperature here. And this is all equal to my latent heat of fusion, 3.3 by 10 to the power of 5, times the mass of my ice. The mass of my ice is 200 grams, so I must convert that into kilograms by dividing by 1,000. Plus, once your ice melts, it is ice water at 0 degrees. This ice water heats up until it is in thermal equilibrium, or whole substance is in thermal equilibrium, i.e. your hot water and your cold ice water have one common temperature. So this is our mass of our ice, 0.2 times the specific heat capacity of our water times our change in temperature. So our change in temperature here, our ice water is going to some final temperature minus 0 degrees. So your ice water is at 0 degrees and it goes up to some final temperature, which I don't know. So I'll keep that as final temperature minus 0. Okay, from here I filled in everything I need to, and now I just start multiplying it out. So 0.5 times 4180, 2090 times 80 minus my final temperature equals 3.3 by 10 to the power of 5 times 0.2, which gives me 66,000 plus 0.2 times 4180 gives us 836, all times our final temperature. Continue to multiply this out and solve for your unknown final temperature. 2090 times 80 gives us 167,200 minus 2090 times my final temperature. So I'm just multiplying or expanding out my brackets here. That's all equal to 66,000 plus 836 times my final temperature. Okay, here I'm going to have my final temperature on one side of my equation and everything else on the other side. Okay, so group together your terms. So this would give me minus 2090 times my final temperature minus 836 times my final temperature is equal to 167,200. Sorry, bringing that to the other side, that's minus plus 66,000. Okay, so I'm just bringing my final temperatures to one side and my other values to the other side. Grouping together my like terms, I now have minus 2,926 times my final temperature is equal to 167,200. 101,200. I now want my final temperature on its own, so I'm going to divide both sides by minus 2,926. And this gives me my final temperature of my water as 34.59 degrees Celsius. Okay, let's have a look at an exam question on this. So this is question 6 of your exam questions. First off, define latent heat. So your latent heat, we know that energy is equal to Lm. So your latent heat is the amount of energy required to change 1 kilogram of a substance to a different state. So L is equal to E over M. In part 2, we're told that a drinking glass contains 500 grams of water at a temperature of 24 degrees. We have 3 ice cubes of 2.5 centimeters each, and they are removed from the freezer and placed in the water. The temperature of the ice is at minus 20 degrees. In step 1, we must find the mass of the ice. So what are we told about our ice? Well, we have 3 ice cubes. And we're told the length of each side. So we're told the length of each side is equal to 2.5 centimeters. We're also told the density of our ice as 0.92 grams per centimeters cubed. How can I use this information to find my mass? Well, I need an equation for my mass. So I know from my log tables that my density is equal to mass divided by my volume. So I have my density, and if I can find my volume, I can find the mass of my ice cubes. I'm told the length of my ice cubes, and the volume of a cube is equal to my length cubed. So my volume is equal to 2.5 cubed. The volume of my cubes is 2.5 cubed, which gives me 15.625 centimeters cubed. I now have my volume, I have my density, so I can find the mass of 1 cube. This gives me 0.92 is equal to my mass divided by 15.625. I want to find my mass, so I cross multiply. This gives me 0.92 times 15.625 is equal to my mass. So my mass of 1 cube is equal to 14.375 grams. So note I am measuring it in grams as my density is in grams. I have 3 ice cubes. So my total mass, I find the mass of 1 ice cube, so to find the mass of 3 ice cubes, I multiply my value by 3. This gives me 43.125 is equal to my total mass in grams. And then to convert this into kilograms, I'm just going to divide my value by 1,000, so that's 0.043125 kilograms. Okay, in part 2, you're asked to calculate the minimum temperature of the water. So in this one, I'm just going to set it up for you and then give you a chance to try it on your own. Okay, so setting this up. Let's see what we have. So again, we have our diagram. So we have our ice, and it's in water, or water is at a temperature of 24 degrees. We know that energy lost is equal to the energy gained. So we have to figure out what's losing energy and what's gaining energy. Okay, what's losing energy? So our hot water at 24 degrees is losing energy. So our water is going to cool down. So our water loses energy by cooling down. So there's a change in temperature. What gains that energy? Well, our ice gains that energy. So our ice is going to gain that energy. First, our ice is at minus 20 degrees. So our ice gains energy. So our ice first changes temperature. So it will go from minus 20 degrees Celsius to 0 degrees Celsius. Once your ice is at 0 degrees Celsius, your ice will change state. So your ice changes state from ice to water. Our ice water is now at 0 degrees, and our ice water will then heat up. So then our ice water, so remember this is in liquid form now, our ice water changes temperature. So it goes from 0 degrees to some final temperature. Remember, the final temperature of your water and the final temperature of your ice water will be the same, as they are in thermal equilibrium. Okay, so putting in our equations from here, we have mc delta T of our water is equal to mc delta T, where C here is the specific heat capacity of your ice, plus Lm of your ice, where L is your latent heat of fusion as it's changing from an ice to a liquid, and your mass is the mass of your ice, plus mc delta T, where C here is your water, so the ice is changed to water, and then it changes temperature from 0 degrees to some final temperature. Okay, can you fill in the equation from here?